I need to be in the focus of all attention.
I'm gonna say I should have gotten it right.
Yeah.
Technically, she's still in.
Yeah,
So
you
focus
should have.
of attention because you're recording.
I know. All right, so today is Thursday. Tomorrow is Friday. Monday is Monday. And those are the days that we are going to be doing geometric sequences and series. So we did arithmetics last week. We're going to do geometrics this week. Next week, Tuesday, is a formative in the Resource Center. Next week, Wednesday, is a quiz in class. And then we're on to the next topic after that. Okay? Hopefully wrapping up by the 19th. So hopefully we're still on pace to. Okay. Hopefully on pace to test on the 19th. I will tell you that next week, Friday, is a Chromebook and earbuds day. And by that I mean you have to bring a Chromebook and a pair of listening devices so that you can watch the video on your own pace in class. Okay? It's not a let's just watch the video on one person's Chromebook kind of a thing. It's a individual type thing. So next week, Friday, Chromebook and earbuds. Okay? We have limited charging holes around the room, so make sure it's a charged Chromebook too. Yep. All right, so a geometric sequence is a sequence that has a constant ratio between consecutive terms. Okay. A constant ratio. So in arithmetic, we added to get the next term. In geometric, we are going to multiply. By something. And that something, back in arithmetics, was called D. D is what we added, the common difference, or the constant difference. We added to each term to get the next one. Now we're going to call it R for the ratio, the constant ratio. And the ratio is any term divided by the term right before it. Or the previous term. Or G sub n divided by G sub n minus 1. Okay. We're switching from A's to G's. Okay. G for geometric, A for arithmetic. So all of your formulas, if it's an arithmetic formula, will have A values in it. All of your geometric formulas will have G values in it. It's one way that you can tell the difference. Okay? So let's take a peek at some sequences and let's decide if they are or if they are not geometric. Okay? Since we have arithmetic things in our toolbox, I would first always check to see if it's arithmetic. So here we added 2, here we added 4. So right there, that tells me it is not arithmetic. Okay. So then I look to see if I can multiply by something. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 multiplied by 2 is 32. So this would be a geometric sequence. And the R value would be any term divided by the term right before it, or what we multiply to get the next term. So my constant ratio is 2. 32 divided by 16 is 2. 16 divided by 8 is 2. 8 divided by 4 is 2. 4 divided by 2 is 2. Yeah? Nick, put it away. No? That's not putting it away. That's just turning it off. Yeah? Next one. Arithmetic. No, because at first we subtracted 100, then we only subtracted 50. So it's not arithmetic. So that's out the way. Okay? Geometric. Is it geometric? Yes. What's my R value? 1/2. Yep, because every time I'm multiplying by 1/2. Third one. Arithmetic? No. You can automatically tell that it's not arithmetic because it's switching signs every time. Okay. Geometric? What's our R value? -2. What I'd like you to do now is I would like you to determine if these 4 sequences are geometric. And if they are geometric, find the common ratio. First one, geometric? No. But it is arithmetic, okay? Because we're adding a constant 10 every time. Second one, geometric?
Yes.
Yes, what's my R value?
4.
Third one, geometric?
Yes.
Yes. R value? -1/3. Yep. Fourth one, geometric?
No.
No. Arithmetic? Yes. What's my common difference? 2. Yep. Adding 2 every time. So we need a rule. And there it is. Any term in our geometric sequence is equal to the very first term in our geometric sequence times our common ratio raised to the n-1 power, where n is the number of terms or the term number that we are looking for. Back when we were in arithmetic land, we needed 3 things in order to find any term. We needed the first term, the common difference, and the term that we wanted to find. Here, same thing. We need the first term, the common ratio, and the term that we are wanting to find. Let's put it to work. we want to write a rule for the geometric sequence. And then we need to find the 7th term in the geometric sequence. Okay? Well, remember that we need the first term. What is the first term of this sequence? 4. We need the common ratio. Remember, the common ratio is any term divided by the term right before it, which in this case is 2. Then if I utilize my rule, that would be G sub n is equal to 4 times 2 raised to the n minus 1 power. That would be my rule. Then it asked me for the 7th term, or it's asking us to find the 7th term in that sequence. So G sub 7 would equal 4 times 2 to the 7 minus 1 power. 7 minus 1 is 6. 2 to the 6th power is 64. 64 times 4 is 256. First term is 2/3. My common ratio, R, is any term divided by the term right before it. Usually it's going to be easiest for you to take the first 2 terms in a sequence. Okay? Dividing fractions, what do we do?
Switch or you multiply and then switch the fraction you're dividing. So you do that later.
Can somebody clear that up a little bit? I'm still confused. When we're dividing fractions, what do we do?
So wouldn't you multiply the numerator times the denominator, except you turn the denominator into reciprocal or something like
So multiply by the reciprocal?
that? Yes, perfect.
Okay, all right. So this really is 1/2 times 3/2. Which is 3/4. So G sub n would equal 2/3 times 3/4 raised to the n minus 1 power. Fractions are our friends. We're okay with them. Now we need to find the 7th term. Oops, jumped too far. G sub 7 is going to equal 2/3 times 3/4 to the 7 minus 1 power, which is 3/4, excuse me, to the 6th power. 3/4 to the 6th power is 3 to the 6th power over 4 to the 6th power. The 3 on the bottom will cancel out one of the 3's on the top, leaving it 3 to the 5th power. That gives me 2 times 3 to the 5th power is 729. 4 to the 6th power is 64 times 4 is 256. 4,096. Two can go into 4,096, 2,048 times. Rat, I know you're not going to like this next statement. Fractions only. No decimals. Hey. Different style of problem. Write a rule given one term and the common ratio. Okay. So, based off of the fact that this is the 6th term, that would tell me that negative 16 would equal g sub 1 times my r to the 6 minus 1 power. Six minus 1 is 5. Two to the 5th power is 32. So I get negative 1/2 as my first term. So my rule is negative 1/2 times 2 to the n minus 1 power. Try letter D. Four minus 1 is 3. Negative 3 to the 3rd power is negative 27. 12 divided by negative 27 both can be divided by 3 is negative 4/9. So any term in my sequence is negative 4/9 times negative 3 raised to the n minus 1 power. Questions, comments, concerns, clarifications? Write a rule given two terms. So now we have to set up two sets of equations. So this is going to be 48 is equal to my first term times my ratio to the 4 minus 1 power. So this is going to be 48 equals g sub 1 times r cubed. My other one, 1,536, is going to equal g sub 1 times r to the 9 minus 1 power. So that's 1,536 equals g sub 1 times r to the 8th power. Then what you're going to want to do is you're going to want to look at one of those two equations, and you're going to solve one of them for g sub 1. I would choose the one that has the smaller exponent. So I'm going to solve that for g sub 1. If I do that, I get 48 divided by r cubed equals g sub 1. Now what I'm going to do is I'm going to take that and I'm going to plug that in for g sub 1 in my other equation. Thus allowing me to solve for r. If I do that, I get 1,536 equals 48 r to the 5th power. I would divide both sides by 48. 1,536 divided by 48. 32. 32. Still need to solve for r. So now what am I going to do? Just a plain old root. E. Fifth root both sides. Fifth root of 32. 2. Fifth root of r to the 5th. That's just r. Now I can go back to my g sub 1 equation, and I can substitute in 2 for r. Two cubed, 8. So then this is 48 divided by 8 is 6. Now I have enough to write my term, or my rule, I should say. So any rule or any term here, g sub n, is equal to 6 times 2 raised to the n minus 1 power. Questions, comments, concerns? You try letter F. I would also accept here just -3 to the n minus 1 power. You wouldn't necessarily have to write the 1 times. Questions, comments, concerns, clarifications? No? All right. Do that one. Agree with that? Agree with that?
Yes.
Yes? Yes? 3,072 divided by 48? 64? Yes?
Yes.
Now what? Sixth root it. What is the sixth root of 64? Two?
That's what I got.
I want to do that in my calculator with the sixth root.
Mm-hmm. How?
How?
How? Each calculator is different.
One, two, three, four. So you would go 6 there.
I don't know.
Yeah, I got 64.
Because it's not.
Yeah, but
Why does it look like
Because your calculator is only giving you the principal root. Is it negative? No, so that's not I. But if it were, because it's an even root, right? If it were negative, then we'd have to bring I into it, yeah.
Wait, that's terrible.
Yeah.
That's probably
Yeah, but it was an odd root. I know. All these mathematical rules that you know.
2.6.
What?
6.
98. I can throw out random numbers too.
1,670,000.
You guys know this. I know you do. It's not 2.
But 2 to 6
Yeah,
It is.
So why?
2, 6, 6.
But is that the only one?
You could do 8.
Probably.
8 to the 6th power is a lot bigger than 64.
Positive
One of
and
them.
negative
That's
two.
one of them.
What?
Positive and negative two.
It's plus or minus 2.
Why?
I didn't even think of that.
Because since it's even, it'll be 64 either way.
It's not so extra. It's not so extra. Anytime that you have an even root, it's plus or minus. Right? Because yes, 2 to the 6th power is 64, but negative 2 to the 6th power is also 64. So on this one, not only do you get 2 different R values, you've got 2 different values to plug in up here. So if we plug in 2 to the 3rd power, we get 48 over 8, which is 6. But then I'd also have to plug in negative 2. Ooh, so that's going to be negative 8. So that's going to be negative 6. So that means I get 2 different rules. Both mean my answer. So my first one would be positive 6 times positive 2 to the n minus 1 power. And negative 6 times negative 2 to the n minus 1 power. Both make my answer. Now, if you don't want to do the plus or minus, I don't want to give you all the points. Okay? So it's your choice. You can do half the work and get half the points, or you can do all the work and get all the points. Okay? Because both, excuse me, both of those equations have a fourth term of 48, and both of those equations have a 10th term of 3072. Okay? So I leave that choice up to you. This way. Oh yeah. Yeah. Oh yeah. Fluff the hair in your way.
Every Thursday, yeah. See, there's this trick that